Hello everyone, today we're going to be solving Aqa GCSE Chemistry Foundation Tier Paper 2, June 2018. This particular question paper is the part 2 of the video where we're going to be solving from question number 6 to question number 10. Disposable cups are made from coated paper or polystyrene. Figure 4 represents the structure of polystyrene. You can see the structure of polystyrene over here. Which small molecule is used to produce polystyrene? To make the monomer from the polymer, we'll have to reject these two hands into sides and make double bonding between it. So B is the correct answer. Which process is used to make polystyrene from small molecules? From small molecules to large molecule or poly molecules, that means we'll have to make a polymerization. Complete the sentences. Choose the answer from the box. Polystyrene is produced from small molecules called, so polystyrene is made, it's a polymer, so it's going to be made from monomers. When polystyrene is made, dash styrene molecules join to form large molecules. Many styrene molecules, because in a polymer we have many monomers joined together. These large molecules are called polymers. Paper 4 gives some information about disposable cups. We can see coated paper cups are made from wood. Energy to make one cup is 550. Biodegradable, yes. Recycle, no, we can't recycle it. Polystyrene cups made from crude oil. Energy is less needed. Alright, biodegradable, no. However, we can recycle. Compare the advantages and disadvantages of using coated paper and polystyrene to make disposable cups. Use table 4 in your knowledge and understanding of the cycle assessments, life cycle assessments, LCAs. In a question like this, where we have 4-mark question asking you about advantages and disadvantages, it is good to give both equal points for advantages. So paper coated cups are produced from renewable resource, biodegradable, and that's why they will break down. However, the disadvantages, it requires a high energy cost to make one. Greater amount of fossil fuel is used and thereby leading to pollution, and it cannot be recycled, so it just fills up the landfill. A student investigated how concentration affects the rate of reaction between magnesium and hydrochloric acid. The student uses this method. Point number 1, place hydrochloric acid in a conical flask, add magnesium powder, collect the gas produced in a gas syringe, measure the volume of gas every 40 seconds for 160 seconds. Repeat steps 1 to 4 3 more times. Repeat steps 1 to 5 with hydrochloric acid of higher concentration. What is the volume of gas syringe? So volume of gas in the syringe is here 80 cm3. We can see that 81 to 3, 83 cm3. Which two variables should the student keep the same to make the investigation a fair test? Concentration of hydrochloric acid. Well, the student should change the concentration of hydrochloric acid every time. Mass of magnesium powder. Yes, because the student is going to do the same experiment again and again. Yes, the student must keep the mass of magnesium powder same for every experiment so that the experiment is fair. More magnesium powder in more concentrated acid will definitely produce more volume of gas. Temperature of the hydrochloric acid must be kept constant, because higher the temperature, faster the reaction. Time for the reaction to end, volume of gas collected. These variables, they can be controlled. They are the ones that we are trying to measure. Table 5 shows the student's result for the experiment with hydrochloric acid of lower concentration. We can see there were just 1, 2, 3, 4, and that average was done. Calculate the mean value X in table 5. To calculate the mean value X in table 5, first of all, we have to cancel the anomalous result. And in this case, the anomalous result is 30. So we have to cancel it. And then we're going to add the other 3 and we're going to do average. Plot the data from table 5 on figure 6. You should include your answer to question number 7.3. You do not need to draw a line of specific. Time in seconds. Mean volume of gas collected in cm3. Figure 7 shows the result of the experiment with the hydrochloric acid of a higher concentration. We can see in this experiment the amount of gas produced is faster in comparison with that of the time, and the reaction finishes faster. Calculate the mean rate reaction between 0 and 50 seconds. So at 50 seconds, the volume of gas produced is 80 cm3. Divided by the time taken is 50, which gives it 80 divided by 50, 1.6 cm3 per second. Describe how the rate of reaction changes between 0 and 160 seconds. The rate of the reaction is greatest at the start, then the rate decreases, and eventually that rate of reaction goes to 0 and the reaction stops. The student concludes that the rate of reaction is greater when the concentration of hydrochloric acid is higher. Why is the rate of reaction greater when the concentration of hydrochloric acid is higher? When concentration is higher, then there is more number of collisions per second. That's one thing. And because there are more number of particles in the same volume of acid, so they are very close together and then they collide more often. So high concentration does not give them energy to move faster or does not increase surface area of magnesium. So these last two will be there. The student tests the gas produced by bubbling it through the lime water. No change is seen in the lime water. Give one conclusion that the student can make about the gas. Since the lime water did not change, lime water is sensitive to carbon dioxide. So we will say the gas is not carbon dioxide. The student tests the gas produced using a burning splint. Name the gas the student is testing for. So using a burning splint, all right, we usually test for hydrogen. Our burning splint is used for test for hydrogen. Name the result of a positive test of this gas. So name of the gas will be hydrogen. The result will be a pop sound. This question is about chemicals in fireworks. Colored flames are produced because of the metal ions in the fireworks. What color flame would sodium ion produce? Sodium ion is responsible for producing yellow color. Name a metal ion that would produce a green flame. Green flame is produced by copper ions. Some fireworks contain mixture of metal ions. Why is it difficult to identify the metal ions from the color of the flame? Usually, the flame colors are masked. We only see one color. We see mixture of color. Flame emission spectroscopy is used to identify metal ions in a firework. The flame emission spectra of 5 individual metal ions are flame emission spectrum for a mixture of 2 metal ions. So we can see the flame emission spectra, which 2 metal ions are in the mixture. So in the mixture, we will try to match spectra. You can see there is a matching in the lithium section. So there is a match in the lithium portion. The other one that matches is sodium ion. As you can see, there is a match here. So these 2 ions are present. Lithium, sodium. The compound in firework also contains non-metal ions. A scientist tests a solution of the chemicals used in firework. Silver nitrate solution and dilute nitric acid are added to the solution. A cream precipitate forms. Cream precipitate is when silver nitrate is added, is indicating of bromide ion. So presence of bromide. Describe a test to show the presence of sulfate ions in the solution. Give the results of the test if there are sulfate ions in the solution. Test. Add barium chloride solution and hydrochloric acid solution. Once we are going to add barium chloride and hydrochloric acid, then if there is sulfate present, the result will be white precipitate. Methylated spirit is a useful product made from a mixture of substances. Table 6 shows the mass of substances in a sample of methylated spirit. Ethanol 265.5, methanol 23.3, pyridine 3, methyl violent 1.5. What name is given to a useful product such as methylated spirit? When we produce something like this that has a formulation which we are going to add in certain proportion, we call it formulation. Calculate the percentage by mass of methanol in methylated spirit. So the total mass of the mixture and methanol's mass, we will compare it. So 23.3 is the mass of methanol and divided by 265.5 plus 23.3 plus 3.0 plus 1.5 times 100. This will give us percentage by mass of ethanol. Methylated spirit contains ethanol and is available cheaply. Methylated spirit also contains pyridine, which has a very unpleasant smell. Methyl violet, which makes the mixture purple. So this is why pyridine and methyl violet are added to ethanol to make methylated spirit. They act as, like a way to deter people so that people don't, drink this ethanol solution. So this one use of methylated spirit. Methylated spirit can be used as a fuel, can be used as solvent or antiseptic. Describe how ethanol is produced from a sugar solution. Give the name of this process. From sugar solution, to make ethanol, sugar solution is first fermented. When we use the process of fermentation, we add yeast and then we place this yeast sugar mixture in an anaerobic condition and in a warm place, like around 30 degrees Celsius, so that the yeast can work on the glucose and convert it into, the enzyme reaction can convert it into ethanol. Figure 9 shows the part of the distillate formula for ethanol. Complete the figure 9. To complete the figure, we have to add the alcohol part, OH, and the carbon has 2 more hydrogen, which is added. Name the gas produced when sodium is added to ethanol. When sodium is added to ethanol, hydrogen gas is produced. Methanol is used to produce methanoic acid. What type of substance reacts with methanol to produce methanoic acid? In order to convert any alcohol to a carboxylic acid, we must do a process of oxidation. So to do oxidation, we require oxidizing agent. This question is about gases. Figure 10 shows how nitrogen is used in the Haber process to produce ammonia. Nitrogen gas, gas X, in the reactor, in condenser, condenser to ammonia, and the condenser, the unreacted gas, goes to the reactor. Back again. Gas X in figure 10 is obtained from methane. Name gas X. In order to produce ammonia, we require 2 gases. One is nitrogen, the other is hydrogen. Give the appropriate temperature and pressure used in the reactor. Temperature used for this particular process is 450 degrees Celsius and the pressure is 200 atmospheric pressure. This particular temperature and atmospheric pressure gives the best yield of ammonia. The mixture of gases from the reactor cools in the condenser, such as why ammonia condenses but the other gas do not. Ammonia has a very high boiling point, so it can easily condense when compressed and cooled down. However, other gases such as hydrogen and nitrogen, they have a very low boiling point, so they don't easily condense. The Earth's early atmosphere was different to the Earth's atmosphere today. Scientists think that the Earth's early atmosphere was like the atmosphere found on Venus today. Table 7 shows the amount of carbon dioxide and oxygen in the atmosphere of Venus and Earth today. Carbon dioxide 96.5% in Earth's atmosphere today 0.04. Oxygen was 0.0%. And now it is 20.95%, almost 21%. The percentage of carbon dioxide and oxygen have changed from Earth's early atmosphere to Earth's atmosphere today. Explain the processes that leads to these changes. You see, in the Earth's early atmosphere, we have a lot of carbon dioxide. Those carbon dioxide decreases and oxygen has increased. So they have most likely decreased because of photosynthesis. The photosynthesis decreases the carbon dioxide, oxygen, which is then released. The other way is the carbon dioxide concentration has decreased in today's Earth. That could be, carbonates, rocks are produced. All right. So sedimentary rocks locks up the carbon. All right. And algae and plants evolved. They, did photosynthesis and absorbed the carbon dioxide and released oxygen. However, when they died, they locked up that particular carbon in the form of fossil fuels. Why are scientists not certain that the percentage of each gas in the Earth's early atmosphere? There are very limited evidence, and it occurred 4.6 billion years ago. Guys, thank you for watching the video. See you in the next video, guys.